All right, today we're going to pull back the curtain on something that happens billions, maybe trillions of times a day. How a single piece of data finds its way from your computer across the entire planet and back again in the blink of an eye.
I mean, really think about it for a second. You type an email, hit send, and somehow, out of literally billions of devices, it finds the one correct inbox. How on earth does it not get lost? It feels like absolute magic, but it's not. It's actually a really clever system.
And the secret to that system? Well, it works a whole lot like the regular old postal service. You see, every piece of data you send actually has two different addresses slapped on it, and each one has a very specific job to do. Those two addresses are the IP address and the MAC address. And here's the easiest way you can ever think about them. The IP address is like the full home address you write on an envelope. It tells everyone involved the final destination. The MAC address, that's more like the name of the specific mail carrier who's just taking the letter to the next post office.
So let's break that down. An IP, or Internet Protocol, address is your device's global address on the internet. When your computer sends a packet of data, that destination IP address is set in stone. It will not change for the entire trip. It's the North Star for that packet's journey.
Now the MAC, or Media Access Control, address is a totally different beast. It's a unique ID that's physically burned into your device's network card. Its job isn't to know the final destination. Its only job is to know the very next stop or hop on the journey. And honestly, understanding that one difference is the key to unlocking this whole thing.
To really see how this works, let's follow a data packet on two different trips. First up, we'll do a simple one, a quick trip to a neighbor on the exact same local network. This is basically the digital version of walking next door to hand your neighbor a letter.
Okay, so imagine we're sitting at a computer with the IP address 172.16.31.3. We're just sending a simple test message, what's called a ping, to another computer that's right there with us on the same network at address 172.16.31.2. Now look at how simple the addressing is here. The IP addresses are set. They're the start and the end of the trip. And because the other computer is a direct neighbor, our computer can easily find its specific MAC address and just send the packet straight to that machine. No middleman needed.
So the big takeaway here is that for a local delivery, nothing complicated has to happen. The packet gets created with all the final address info, both the IP and the MAC, and it just goes right there. It's a one and done deal.
But what happens when the destination isn't next door? What if it's all the way across town on a totally different network? Well, this is where our postal service analogy really kicks into high gear.
We're starting from the exact same computer, 172.16.31.3. But this time, our destination is a remote computer with the IP address 10.10.10.2. It's on a completely separate network.
Now, our computer is smart. It takes one look at that destination IP address and immediately knows, hey, that address isn't on my street. It knows it can't deliver the packet directly, so what does it do? It sends it to its default gateway, which you can think of as the local post office for the network. In other words, the router.
And right here is where you see this beautiful system in action. The destination IP address is still our final goal, 10.10.10.2. That's not going to change. But look closely at the destination MAC address. It isn't the final computer's address. Nope. It's the MAC address of the local router. The packet is just being mailed to the post office to get started.
So the packet arrives safely at the router. It's like you've just dropped a letter in the big blue mailbox. Now the router, our friendly neighborhood postal worker, picks it up, inspects it, and gets it ready for the next part of its trip. And this is the most important step in the entire process. Okay, so the router looks at the packet. It sees the final destination IP and says, got it, I'm not touching that. But then it does something amazing. It strips off the old MAC address, its own, and puts a brand new one on there for the next router in the chain. It is literally readdressing the package for the next mail carrier. So, now that we've seen those two journeys side by side, we can finally spell out the fundamental rule that makes the entire internet tick. It's all about how these two different addresses play together on a team. Let's just sum it all up. For any journey, whether it's local or remote, the source and destination IP addresses are constant. They are the start and end points, period. But the MAC addresses, on a local trip, they also stay the same. But on a remote journey, they change at every single hop, at every single router along the way.
You know, here's probably the clearest way to remember it. The IP address is for the final destination city. The MAC address is for the very next truck stop on the highway. One is about the ultimate goal, the other is all about the immediate next step.
Okay, so that's a pretty neat technical trick, but why does it actually matter? Well, it turns out this simple little rule is the foundation for pretty much everything you do online, from your home Wi-Fi all the way up to the global internet.
Because of this system, a router doesn't need to know the location of every single computer on Earth. All it needs to know is the best next hop to get a packet a little bit closer to its final IP destination. This is what allows your data to jump across different networks, across oceans and continents, and it's what provides the basic organization that keeps trillions of data packets from getting lost every second. It is the very reason the internet can scale to a global size and still somehow actually work.
So the next time you send an email or load a web page, just think about that incredible journey for a second. The IP address is the fixed destination on the map, but the MAC address, that's providing the turn-by-turn directions, being constantly rewritten by routers all over the world. It really makes you wonder, doesn't it? Is a journey truly defined by its final destination or by the series of individual steps that actually get it there?